Yes, I got a haircut. It was time. Thanks for asking. We are going to talk about substitution today. And so this is a method that we use when we're doing integration. Uh, Usually when we're dealing, anytime we're trying to find antiderivatives. So if you're just trying to find the family of functions like this indefinite integral, or if you're actually evaluating a definite integral and need the antiderivatives, you can use it for that too. You need to read lesson 5.5 in the textbook. It's not overly long, pretty straightforward, goes through some good examples. Read that. Why do we do substitution? Why do we need to learn this new method for evaluating integrals? Well, sometimes you get integrals that aren't real nice, all right? And that it's not immediately obvious how to go backwards in your mind of, okay, what's going to give me that for a derivative? That's hard to do sometimes and keep track of. So, in my opinion, substitution takes the guesswork out of evaluating some integrals, okay? So eventually you'll have to get good at recognizing when should I use substitution, when shouldn't I. But one hint, I guess, would be a lot of times substitution is used when you have something in parentheses. In this case, it's kind of a function within another function. Okay, this is a function to the fourth power. And then if you think of the derivative of that function, if that's outside of here, that's usually a good indication that substitution will be used as well. We'll do another example here shortly where a lot of times if you have a square root or natural log of something and there's an expression inside of that function, inside the square root, oftentimes you'll use substitution. So here's how it works. Substitution uses a new variable, uses u, so it's often called u substitution. And oftentimes, in this case, once you get good at it, you'll be able to recognize your u a little easier. I think in today's homework, they give this to you to start with, okay? But normally that won't be given to you. You'll have to figure that out. So we're going to say u is 3x squared plus 4. So what we're going to do now is we're going to kind of leave this here, and we're going to work here, and we're going to say, all right, what is the derivative of u with respect to x? Remember that notation? Okay, so the derivative of u with respect to x. Well, this is easy, 6x, right? Now, what we're going to do is we're going to actually solve for du here. So we're going to think about this as actually, this notation is nice because you can actually utilize it like a fraction. So we can multiply both sides by du, or sorry, multiply both sides by dx. That goes away here, so we're left with du is equal to 6x times dx, right? Now, what we're going to notice is that what we have here, the 6x is here, the dx is here, and the original 3x squared plus 4 is here, okay? So we're going to replace all of these things. We're going to substitute, all right? And so here's our substitution. I'll try the green here. So I'm going to take out the 6x and the dx and replace that all with du. Okay, so all of that is just now du, because that's what it said. They're equal there. And then 3x squared plus 4 is just u to the fourth. So we took this whole thing and changed it to this. Now notice, this is a much easier integral to solve. U to the fourth du. And it's very important that that du is the same as the variable we're using. If we still had a dx, that wouldn't work because that's not an x, obviously. So we integrate this, which says we need a u to the fifth, and that's going to be a 1/5 in front of that to make that come out to be a 1 when you take the derivative, plus c. Okay, so we did it. However, that was not the original integral. We changed it to an easier one to get to here. Now we just need to substitute back. 1/5, substitute the u, the 3x squared plus 4 back in, and you are done. You can always check these. Remember, you can take the derivative of this, right? Think about the derivative of this with the chain rule. It'd be 1/5 all of this, sorry, we do the outside first. So we take 5 times 1/5, which is just 1. So it'd be 3x squared plus 4 to the 4th times the derivative of the inside, which is 6x. Oh, that's exactly what we had here. We're good. Okay, so that's the first example. One more for you today. We'll do some harder ones on Monday, but for now, we'll just get started with some easier ones here. So here we go. I'm going to say my u is z squared minus 5, and then I'm going to take du dx, or sorry, du dz, and I get 2z for that. I multiply both sides by dz. So du is equal to 2z dz. All right. Now, notice here, we have the dz, but we have just z here, and we have 2z here. So what I'm going to do is I'm actually going to divide both sides by 2, or think about this as 1/2 times du is equal to z dz. So now all of this will go in here, okay? Or I should say, this part, which is here, is going to be substituted 1/2 du. So I'm going to substitute a 1/2 in and a du in. That goes for these two spots. And then underneath the square root is our u. Okay. Now, we want to think about this as 1/2 u to the 1/2 power du. So I integrate this, and that's going to be u to the 3/2 power. This is going to have to be 3, nope, it's going to have to be 1/3 in order to make that come out to be 1/2 when you multiply these, plus c. And then finally, all we just do is our final substitution. 1/3, take out the u, put in the z squared minus 5 to the 3/2 plus c. Okay, so that was a little harder because you had to think about this constant here. But see what you can do with this today, guys. I got a few problems for you, and have a great weekend.